Here we are, Advent of Code, day 4. And today the problem is with these pairs of sections that the elves are supposed to be cleaning up. And I could read through all of this, but essentially what's happening here is you want to find the cases in which one of these sections is contained by the other. So if you look down here, they give you some examples. So here, the sections 3 through 7 are contained by the sections 2 through 8, and the section of 6 is contained by the sections 4 through 6. So you just want to find how many assignment pairs does one range fully contain the other. That's all. And the input is going to look like this. So let's go over to, I'm going to do this one in Replit today and start off. Get some stuff arranged here and start off by reading in our input data, and I've got a file called test input here, and then the larger input that we'll use later on. All right, so I'm actually going to do everything in one step. So say input.text for reading as f. I'm going to say data. I'm going to use list comprehension. I'm going to take each line, I'm going to strip off the white space on either end, which will be the new line in this case, and then I'm going to go ahead and split it on the comma. And that's going to return a list, and I'll do that for each line in f.readlines. And so this will end up giving me a list of lists. And then I can start my total for the total number of sections that are fully contained by another section. And I'll say for section pair in data. Now what I want to do is I want to extract the start and end points of each section. So I'll say section 1 dot start, section 2 dot start, and then I'll use another list comprehension. And for each of the numbers that's separated by a hyphen, I'll turn them into an integer. So that'll be section pair, the first section, and I'll split that on a hyphen. And then to get the other one, I can simply copy this. Actually, that's wrong. This should be section 2, and now this should also be section, nope, that's already right. And then section 1. Now it turns out that if we can ensure that the second section is always contained by the first, that we only have to write one, we only have to write the code once to do this. So I want to make sure that the first section always starts earlier than the second one. So if that is not true, in which the first section starts after the second one, I want to flip these. And the easiest way to do that, probably not the most efficient, but the easiest way to do that is to copy and paste this and flip the pairs. All right. Now let's take a look at what happens in the case that one section contains the other. So I've got some slides here. And this is what it looks like. So in this case, the first section here contains the second section. And as you can see that this is what the case is, that the start of the first section is greater than or equal to the start of the second section, or I'm sorry, the start of the first section is less than or equal to the start of the second section, and the end of the first section is always greater than or equal to the end of the second section. So let's go back to the code and add that. So if, let's clean it up a little bit, if section 1 start is less than or equal to section 2 start and section 1 end is greater than or equal to section 2 end, then simply add 1 to the total. I made a terrible mistake here. And this is, of course, why you should never copy and paste code. But I think now I did not mess this up too much. All right, I believe that should be correct. Okay. Now it turns out that there's an edge case, and this doesn't catch all of them. Let's go back to the slides and look. And the edge case has to do if the sections start at the same place. Now, if the sections start at the same place and the first one contains the second one, there's no problem. But remember, we're swapping only if the start of the first section is greater than the start of the second. Well, that doesn't catch this case, in which they start at the same place, but the end of the first is actually less than the end of the second. So we're going to have several instances in which they start at the same place, but we didn't catch those. So we can go ahead and just catch those remaining instances here. And we'll say elif section 1 start is equal to section 2 start total plus equals 1, and then we can print the total. All right, and Replit reformatted for me. However, if I run this, I should get, yes, 569 for the total input, which is the correct answer. All right, part 2 turns out is super simple. Now they just want to find out how many pairs overlap, period. Whether they're contained or not, whether they overlap at the front, whether they overlap at the end, it doesn't matter. Let's go back and look at one more slide. So it's actually easier to find the ones that don't overlap and subtract that from the total number. All right, and that's simply when the end of the first is less than the start of the second. So again, for simplicity, I'm just going to copy all this and paste it. And all of this here still works. I just have to take this out and replace it. And I'll just say that if section 1 end, and this is now we're counting again, not the sections that overlap, but the sections that don't overlap. Section 1 end is less than section 2 start total plus equals 1. And now I just have to subtract that number from the total number of pairs, section pairs. And let's run this. And we get 936, which again is the correct answer.